Yeah, hello everybody. You can hear me, right? Very good. Okay, you already see my talk, and I know that's working good. Maybe now it's working better. I know RxJS is super difficult. Who of you have already bad experience with RxJS? Hands up. Oh shit, that's a lot more than I expected. Okay, don't worry, we will get that. Because that's why I'm here. I want to finally get rid of this. So before we dig into that, let me shortly introduce myself. My name is Niklas. I'm 23 years old, 24 years old. I'm software consultant for a medium-sized German consulting company. And since roughly a year, I'm a member of the RxJS core team. Additionally, I'm doing some meetup stuff. I'm organizer of the Engineerei meetup, which is a meetup with like 50 attendees at maximum. And if you want to get in touch with me and don't know what you want to talk about, I'm absolutely a barbecue lover. So here's the icebreaker. Feel free to talk with me about that. I'm super happy about it. Okay, let's start. What is RxJS about? RxJS is mostly about reactive programming because it's the default or standard library for reactive programming in JavaScript. So the better question, instead of asking what is RxJS, is what is reactive programming? Reactive programming is a kind of mindset. A mindset how you handle your data, because you look from it like a point of, it's a stream of data which come over a certain amount of time. It can be there immediately or it can come somewhere. We don't know when. So that's the basic idea. Everything is a stream. That's the main important thing about reactive programming. Besides that, a stream can represent 0 to infinite values, which comes over time, like I already said. Also, stream can end at some point, but don't necessarily need to. So it could also mean that we have an endless stream running forever and taking a while. So now that we covered what is reactive programming, many of you may ask, why should I care about it, right? Right? Yeah, there are some nodding and there are also. So reactive programming is super awesome for asynchronous and event-oriented programming. So all the time, if you're doing complex, asynchronous, or event-oriented stuff, RxJS is definitely the best way to go. I promise you, without any biasing. Sure. A nice side effect of that is it also unifies promise, callbacks, and event handler, because many of you already might know that all of them has a slightly different syntax and some nitty-gritty details. RxJS can handle all of them. Additionally, RxJS is very stable. It's already existing for 10 or 11 years already. It's intentionally developed by Microsoft. Thanks for that. And it's completely framework agnostic. So you can use it with React. You can for sure use it with Angular, with Vue, with plain JavaScript. Doesn't matter. But for sure, there are some downsides. Because I already said, it's super, super complex to get into it. Especially the start is super tough. One point I have to admit is that the documentation could be much better. So many of you may notice that the marble diagrams are broken on the official docs. That's my bad. Sorry for that. I'm working on it. And it's also difficult to debug. So if you want to debug your code, it's not that easy as usual JavaScript code. OK, so to get a basic or rough idea what RxJS is about, I want to talk about the common terms so that we are all on the same page, right? So the most important, and all of you have to know about, is the observable. An observable is, like I already said, a stream. It's a set of values from 0 values to infinite over a certain amount of time. It's also read-only, so that we can't manipulate it directly, because we are just a consumer of values. So we just get some values and can do something with it, but we can't manipulate it, right? An important difference to some other reactive implementations is that we have 3 channels. One is the next channel, which is mostly used. One is the error and the complete. So error is thrown for sure when an error occurs, and the complete when the end streams. Makes sense, right? So an important thing here to mention is that an error event also completes the stream. So after an error, the stream is dead, right? And one thing many complain about is that RxJS is black magic and some magic is happening here and there. It's just a plain function. I promise you, I checked the code, it is. I promise. Let's come to the next one, it's the observer. An observer is the internal nitty-gritty detail of the observable. So this is the thing where the values come from. So in most terms, developers don't interact with that observer, right? It's just an interface providing this interface for next, error, and complete, and we can provide the values with it. But in most terms, the framework already took care of it. And just for you to know the difference, where are my values coming from, and to know for you what are the basic terms. Let's come to the subscription, because many of you already know that you have to subscribe to an observable, right? Observable subscribe, super common, super common. And this method call returns a subscription instance. This subscription instance represents the execution of one observable. The nice side effect of that is that the subscription instance also provides an unsubscribe method, which will make an observable complete. So that's the main use case of storing a subscription instance in a property. But we will come back to that later. And last but not least, the subject. We already heard a lot of that, but just a quick summary. In general, it's just a combination of an observer and an observable. So what it has the power of an observable, but exposes the value propagation mechanism from the observer, so that we directly can opt in values into that observable via the subject. Additionally, there are, I think, like 4 or 5 types of different kind of subjects. You can use those. All have a slightly different behavior, but for now, it's just totally enough to know there are subjects, and they are super cool, especially for lightweight state management, like Jesse already proposed. Okay, so we now have the basic entities in RxJS covered. Let's come to the notification. A notification is basically just a value. So every time an observable emits something, it's a notification. The thing why we don't call it a value is because it can also be undefined, void, or whatever. Who of you has already used an event emitter at some point? An Angular, an output event emitter, right? It's basically just a subject, and there you can also emit undefined or void. It's nothing different. So as soon as you will dig into RxJS, you will hear those terms, lazy and eager. Everywhere it's stated, yeah, observable is lazy, it's super awesome that it's lazy, and no one has a clue what this means. At least I didn't. So lazy means just that the execution kicks in when you really need it. In this case, it's just when you call subscribe, right? Nothing before happens. And eager means it directly happens as soon as you call a function, for example. So as mentioned already, no black magic, just some fancy terms for basic stuff. How to encode observables? Who has known this term? Okay, that's good, that's good. Who knows the difference? Okay. So a code observable means that the producer of the values is created inside the subscription. This leads to the fact that every subscriber, so I have an observable and I have multiple subscribers to that. Each of those get its own instance. So we can think about, for example, an HTTP call, right? We're having an HTTP call which is created inside the subscription. This leads to the fact that every subscriber gets a new instance of the HTTP call, and the HTTP call is requested again every time for each subscriber. That's what cold observable is about. And in general, most of the observables are cold as long as you don't do anything about it. A hot observable means that the subscription instance is shared across all the producers. So if I have made the HTTP call and just store the value, for example, and then pass it to my observable, then this one is shared across all the subscribers. I did the HTTP call once, and then it's a hot observable. That's the difference, right? Great. So now that we have talked about the basic terms, let's come to the operators. Operators are the most powerful thing or the added value of RxJS, because this allows you to manipulate and do all the amazing asynchronous stuff with RxJS you would like to do. In general, there are two different types of operators. There are the pipeable operators, those you can pass to the pipe function. Nodding again, very good. And there are a static or creation operator. Those are used to create an observable from whatever, a promise, from an array. So those are the two differences, and they are very composable because you can aggregate them. In the pipe, you can add multiple, those kind of things. A very important thing to know is that operators aren't or RxJS isn't asynchronous by default. Because I often heard the fact that, okay, as soon as I'm using RxJS, I have to deal with all these asynchronous things. It's not like that. RxJS tries to be as synchronous as possible. Okay? Okay. So now that we already talked about what operators are, I would suggest to get into that. There are at the moment, I think, 104, and we are already considering the 105th one, operator for RxJS. And some of them are super specialized. So there are some use cases, I don't even know about such use cases. And especially at the very beginning, when you see the docs, you will feel overwhelmed by it because you have so many possibilities, so many details you have to be aware of. It's very hard to get into that. But the very good thing is you don't have to know all of them. Afterwards, I will present you the operators which you should know. There are like 7 to 8 or something like that. And afterwards, if you feel comfortable with it, dig into it step by step. So if you want to get out of this talk with one thing to remember, you don't have to know all operators. Really, I promise you, I don't do, Michael don't do, and I'm quite sure Ben also don't know all by heart. Hopefully. So let's come to the operators I want to show you. So who knows array map? Array map, come on. Yeah? So array map or observable map doesn't matter in this point. It just takes the value, pass it to a function, do some manipulation with it, and return it. So in this example, we are emitting 1, and the output is 2. So we are just transforming it, mapping it to a new value. You can use that for transforming your objects into a new kind of structure, those kind of things. So it's very common, super common, and super easy. From is one of the creation operators I already mentioned before. You see there's no stream before because we just pass an array there and it creates an observable for us. And in this particular case, from is working with nearly any kind of data structure. It's also taking promise, I think plain objects, arrays, I don't know what else. So in this case, we pass an array to it. And what happens is that we get an observable out of it. Amazing, right? Filter is pretty similar to map for those who are already aware of the array functions, because we are just filtering out values that didn't match a certain condition. In this particular case, we are checking for even numbers. Even numbers, yeah, even numbers. And those values who didn't match the condition aren't passed to the output observable. Okay, very easy. You can use this for null checks, for undefined checks, checks for whatever. So now we come to a more or less complex part, but I know that Michael will elaborate on that later. Maybe, we don't know. Concat map. So in most business application, if you are trying to be as reactive as possible, you will have multiple streams, and sometimes you want to pass some value of one observable to another one. So we can think of an example for, let's think about a form. Okay, we have a form and its input. The input is passed to an observable, and we want to pass that value to some HTTP request to make a type ahead search or those kind of things. And with those kind of things, we can, for such situations, we can use concat map, because what happens, it takes the value, passes it to another observable, and returns the output. So in terms of the form and type ahead search, it would use the input of the form, pass it to the HTTP request, and return the HTTP response. Okay? Concat map is the most safest to use operator for those kind of things, because it's concurrent. So if you have multiple HTTP requests, it will do them by order. So for example, if you want to delete multiple things, it will do them by order, one by one, and take care of the concurrency. I love tab. I truly love the tab operator, because that's the best way to debug your code. I will come back to that later, but what tab does, it's made for side effects, any kind of side effects. So you can do start or stop animations with it, do some other amazing things with it, but you can't manipulate the observable itself. You get all the events, all the next error complete notifications, everything, but you can't manipulate them. So it's very safe to use and super helpful for debugging. I think we come to the last one, combine latest, because often, I already said, you have multiple observables in your application, and sometimes you want to have multiple values, you want to combine them. And with combine latest, that's the one at least I use the most often, you always get the latest value of both or n, you can also pass multiple observables there, of all observables. So every time there's a change in one of those observables, you will get notified by it. English is a very difficult language. Okay, I lied to you. It's not the last operator. Oops.
Oops.
Okay. Take until. Yeah, my bad. Okay, take until. Take until is very important, especially in Angular application, because what it what you can do with it is you can end a stream. At some point in your application, you don't want to be notified by an observable anymore, for some reason, whatever reason. And with take until, you can pass another observable to it, and as soon as this observable in this diagram labeled with stop emits a value and completes, the output observable ends. Okay, so you can couple that to your component lifecycle. As soon as the ng-on-destroy hook is called, end that stream, and you're good to go. Easy. There were no operators anymore. Very good. So let's talk about pitfalls, and especially how to avoid them, like this amazing runner, who's much fitter than I am. So often in forums, channels, whatever, I see this particular questions, or something like, yeah, RxJS is super awesome, but I can't do anything with it because I don't get any values from an observable. And in 99% of the cases, the one just forget to call subscribe. So besides the thing with the operators, and yet you don't have to know all about, that's the second important thing you should take with you from that talk. Always call subscribe. Anyway, anytime, just do it. You can also use the async pipe for that. The async pipe is internally also calling subscribe, so that's very good. Now that we've talked about subscribing to an observable, do I need to unsubscribe? There's a highly discussed article by Ben Nash about why I shouldn't unsubscribe from an observable. So do I really need to do that, right? Yes, you have to. Because what happens if you don't unsubscribe from a stream is that you can run into memory leaks because you have multiple subscription instances running. You can have bad functional requirements that you implement wrongly in that particular case. And you can have also unplanned side effects. And I run into that situations. It's super difficult to find out what's happening and what's going on and how to fix it. So the diagram displays here with the not that super visible line where you should unsubscribe, or where you wanted to unsubscribe intentionally. But because you shouldn't, you will get additional values which could break your application, right? And no one wants that. So there are three ways of unsubscribing. The first one, and the most easiest one, is just pass the return value of the subscribe method to a new property, a const, a variable, whatever, and call unsubscribe on that. The other one is use one of the completion operators. I don't talk about all of them, but I talked about take until and how it's working. So use one of them, and afterwards your observable completes immediately. You won't get any new notifications, and you're super good to go. And the last way of handling unsubscription is use the async pipe, because besides of subscribing, it's also unsubscribing to your observable regarding to your component lifecycle. So I personally prefer this way. I always try to use the async pipe as much as possible. Sometimes you want to do some side effects and those kind of stuff, then you need to subscribe in that component or whatever, but try to use the async pipe. So, change detection rabbit hole. Probably no one of you has a clue what this means. I like to refer to that term very much because I multiple times saw code like this. Everyone can read that, right? So what we have is a private property, a private observable, and expose it via a public function. Super common, right? In Java and pretty much every other programming language, you're exactly doing it like this because it's super good. But that's not that good. Not good. Who of you knows how functions behave in change detection cycles? Awesome that I make such a highly sophisticated diagram. So what happens if you pass a function to a template? Every time a change detection cycle happens, this function is re-evaluated every time with every change detection cycle. So what happens in our case is we return the observable from that function, subscribe to it, run a change detection cycle, so the function is re-evaluated, we subscribe to it again, and so on and so forth. And especially if you're doing HTTP calls which are triggering a change detection cycle, you are running in an endless loop. Amazing. So how to get rid of it? Easy, right? I don't need to elaborate that much on it. And just instead of using a function, use a plain property. It's totally fine to do that. Everything is lazy evaluated, so everything just happens as soon as you subscribe. No worries. Also works with dependency injection. Super good to go. I added a stacklet so you can play around with if you like to. It's not that much of code, but I thought it could be handy. So now that we already talked some nitty-gritty errors you can run into, how about error handling in general? Okay? So I already said that as soon as an error happens in your observable, the stream dies. And in most cases, this is totally fine. Because, for example, if we take a look at an HTTP call again, when there's an error that the stream is dead, fine for me. Makes totally sense somehow. But there are use cases where you don't want this behavior. You want to keep that stream alive, right? Because, for example, if you're doing polling, where you want to request every 10 seconds, you don't want that stream to end just because the server is not available for a second or whatever reason else causing an error. So what you can do, and I'm sorry that I already lied to you because this is the last operator I will present to you. It's a catch error operator. There are multiple error handling operators, but this is the easiest and most common one. Catch error is just triggered in case of an error, and you have to return an observable emitting an item or whatever. And this one is used for the output stream. So in this case, we are returning an empty observable, so there's no value passed to the output observable. In most cases, so for example, if you're fetching a list from an HTTP server, you could also return an empty array, all those kind of things, or an observable of an empty array, depending on your use cases. But be aware, you have to return an observable from it. So now that we've talked about error handling already, before we run into the situation of handling an error, we may want to debug, right? I already said debugging is super hard, and it truly is because you literally can't put any breakpoints there. Breakpoints are difficult because you're aggregating complex asynchronous behavior, and making a breakpoint in an asynchronous behavior is somehow weird, right? Because you're related to time and those kind of things, it doesn't make that much sense. So I truly advise you to use the tab operator and passing a console log there. It's the best thing you can do to debug your RxJS code. It also shows you how your operators behave after another, because you can just put the first time tab, call another operator, put a tab operator afterwards, and all those things works very great. My code exactly looks like this. Besides that, you can also use RxJS Spy. It's a library from one of the core team members, Niklas Jamieson. He's doing very much into that so that you can observe observables and how they behave. It's a little bit advanced, so if you want to get into it, use the tab operator. If you're a bit more familiar, check it out. It's a very cool project. So now that we have talked about all the most important parts of RxJS, I want to give a brief overview about the future of RxJS and what's happening in the next few months. So before we start with that, I want to talk about the latest version. I think 3 weeks ago, roughly, we published RxJS 6.4. RxJS 6.4 was intentionally planned to just have improved typings, and it has, but it also has a breaking change, which is very unfortunate. The breaking change is unintended because internally we built upon TypeScript 2.8 for a year, roughly, but we didn't promote that. So there are applications out in the world which are running on TypeScript 2.7 or whatever, and this is not working with the RxJS 6.4. And it can also happen to you if you're using a certain version of the Angular CLI. So if you run into that issue, you will have a compilation error. Check out the GitHub issue I linked here. We have, we added there what you can do to fix it, what's the easiest way, and also are interested in what your experiences. Okay. Great. Besides the breaking change, we have also made some new features. For those of you who know the take while operator, we have now added an inclusive option so that the last notification which made that observable complete is anyway emitted. It's a non-breaking change because it's just an option you have to pass, and the default is still like it used to be. And besides that, we truly improved the docs so much with the latest release. For example, we added StackBlitz integration. You know StackBlitz? Some activities here. StackBlitz, very great. So every code example inside the documentation website, there's now a button, show me that code in StackBlitz, and it's directly generated from the source code. You get a version of that StackBlitz example. You can play around with it, see how it behaves. And in most cases, for the operators, we also have at least one StackBlitz now. One thing we used to have in the old docs is a choose your own operator widget. Where you have to answer some questions like, okay, I want to create an observable from an array, and I want to do this and this and this with that. And at the very end of this process, the widget says you, okay, you should use that operator. Here's a link to the documentation of it. Check it out. It's very cool. So there were so many complaints about it, besides the broken marble diagrams, that we made it finally, and I'm very proud that it's finally made it into the official docs. So now that we talked about the latest release, let's talk about RxJS 7. RxJS 7 is, I think Ben already talked last ngconf, which is now roughly a year ago, about RxJS 7, and we plan for no breaking changes. So that's we hope to get this done, but the main goal is to reduce the bundle size. That's our main goal we want to achieve somehow. So there is some complex stuff Ben is doing at the moment, and no one has a clue what's happening there, and I really don't want to know. Besides that, we are constantly trying to improve the typings, because TypeScript isn't that well, or wasn't that well made for functional programming we heavily rely on. So there is huge space to improve, and especially Google is relying very much on that, so we are trying to do that constantly. Some of the operators used to have a scheduler arguments, which bloats the code so much, and this might be one point we will use to reduce the bundle size. This could be a breaking change, but we can I think in most cases we can provide, like we did with RxJS TS-lint, some migration paths automatically for that. And for sure, we will remove the deprecated API. So in RxJS 6, we deprecated the result selector and some other API. This will now be removed. That's like we handle deprecated code. Please be aware what I just said. Plans are made for change. I don't promise you that any of those will happen, and I definitely won't commit to any bundle size after V7 happens. It may also be that there are breaking changes. Everything can happen. So this is just the overview of what we are currently planning. Things may happen. Everyone in software development knows less. I've added you some resources over there so that you can check them out if you want to get into that. I'll share the slides anyway over Twitter, so you don't have to make a photo, but you can. Feel free. Everyone ready? No, there are some cameras, okay. Okay, so now that the official part of my talk is nearly done, I want you to try out to contribute to the official docs. I know that might be scary at the very beginning, but that's the way how I get into the RxJS core team. That's the way I learned so much about RxJS, and it's super helpful. You can increase your knowledge by digging into it, and you can also spread your knowledge. If you already are familiar with one of the operators, which might be poorly documented, I don't know who did that. But anyway, we plan some very cool features. We are planning to do some internationalization. For example, this is for native speaker, this is super easy to do, right? You're just having to translate something. You don't even know about the topic itself. But for us, it's super difficult because we just can't do it, right? So that's the most important part where we heavily rely on the community to support us with it. Besides that, we plan a section about comparing operators because we have many operators which behave similar but not completely the same. That's why we have multiple of those. And we want to have a section where we say, okay, those 4 operators, for example, are similar, but there's a detail which made the difference, and you should not use this, and whatever, right? And anytime we need to improve the API docs, I think last week I still stumbled across an operator which isn't documented at all. So there's huge space to improve, very much. So if you want to get into that, reach out on Twitter to me or here on the floor. I'm very happy to support you as much as I can with that. I really appreciate any contribution to that. And the last thing I have to say is I'm very much appreciating being here today. It's a huge pleasure for me. Thank you very much for your attention.
Thank you very much, Jan. Guys, once again, let's give him a big hand.